Hi guys, it's the first section in Chapter 9. We just finished Chapter 8. So most of it is solving quadratics. We're going to do a little simplifying of radicals first in Section 9.1. Alright, so if you remember your square roots, and remember another word for square root is radical. Square root of 25 is 5 because 5 times 5 equals 25. Square root of 49 is 7, and square root here is 4. Okay, this also works with fractions. You could think of it as the square root of 100 over the square root of 225. So taking the square root of the top and then the bottom as they're both perfect squares. So that would be 10 on the top and 15 on the bottom. That would simplify by 5. So my final answer there would be 2/3. So I'm not going to rewrite it, I'm just going to put the radical top and bottom. So the answer to the second one is 4/5. And the last one would be 13 over 25. And all I'm doing there is taking the square root of the top and then the square root of the bottom since they're both perfect squares. All right, so you're going to want these perfect squares up to 15. You're going to use them a bunch. So you want to write them somewhere where you can get to them, that you can use them again and again. So 1 squared is 1, obviously. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. And I believe that's all you need for today. If we need more, we can use our calculator if we need anything bigger than that. Okay, a radical expression is an expression that contains a square root or a radical symbol. Okay, so any of these down here at the bottom, these are all radical expressions. They'll have radical symbols or square root symbols in them. The radicand is the expression that's underneath the radical sign. So in this example, 5 is the radicand because it's below the square root sign or the radical sign. You know a radical expression is in simplest form if what is underneath the radical sign does not have any factors that are perfect squares other than 1. So, for example, 5 times 1 is 5. If you took the square root of 5, you'd have to use a calculator because it would be a decimal. And if you take the square root of 1, that doesn't matter. That doesn't change either the outside or the inside. So here, x times 1 is x. Square root of 2 times 1. So if it wasn't a perfect square, like for example this one right here, this 12. So when I think about 12, the perfect square I think of as 4. So I could rewrite this as 4 times 3. So it's not simplified because I would have to take the square root of the 4. So square root of 4 is 2. So on the outside, that'd be 3 times 2. The 3 was already out there. Took the square root of 4. Okay, then 3 times 2 is 6. So the simplified answer of 3 radical 12 is 6 radical 3. And we'll go over more how to do that. Okay, so when we find perfect square factors, we use the perfect squares that we just wrote down to simplify them. So what we do is we look for any perfect square factors that exit from the number from the radical sign. We take the square root of those perfect squares and we leave the non-perfect square factors under the radical sign. So for example, the square root of 300. So again, if I know you have that list, but 1, 4, 9, 16, 25, I'm just going to write a few of them. 36, 49, 64, that was 8, 81, 100. Okay, I'll just write those for now. It serves me for this 300. So if I look at 300, well, there's lots of factors of 300, but the highest perfect square would be 100. So I could break 300 into 3 times 100. And 100 is my perfect. So I'm going to take the square root of 100, which is 10. So that's going to come outside and be 10, and the 3 stays inside. So 10 radical 3 is the simplified form of radical 300. Same thing for 20, except 100 is not a factor. So you're going to look up here for factors that can be taken out of 20 that are perfect. Well, 1 can go for any. So 1 doesn't change anything, so we're not going to use 1. But I'm thinking 4 times 5, or 4 is the perfect one. I can take the square root of 4, and that's 2. And the 5 is not perfect because if I put it in the calculator, it would give me a decimal. So 2 radical 5 is the answer. All right, so let's give these a try. If you would like to just pause and give these a try by yourself, remember you're looking for perfect square factors of these particular numbers, and you want the highest one you can find. Okay, so 52. So if I don't know, I use my calculator. So let's try 4. So 52 divided by 4. That gives me 13. So that has to be it because 13 is prime. So I'm going to rewrite this as 4 times 13. 4 is the perfect. So that's 2 radical 13. And all I did was take the square root of 4. So here, 8 times 9 is what I'm thinking. But 8 times 9, that one is perfect. But isn't 4 also 4 times 2? So 9 times 4 is probably 36. Let's see. 72 divided by 36 is 2. So I'm going to use 36 times 2. So if I take the square root of 36, that is 6, and the 2 stays under. So 6 radical 2 is the answer. Okay, radical 24. Let's see. 4, definitely. Let's do 4 times 6. 4 being the perfect. So 4, the square root of 4 is 2. 2 radical 6. 6 doesn't have any perfect square factors, so that's the answer. We've already done 20, so we'll skip that one. The square root of 32. Let's see. 4 works, but I think 16 is better because it's bigger. 16 times 2, yeah, that's the best one. So 16, the square root of that is 4. 4 radical 2 would be my answer. So hopefully you tried those before me and you came up with a couple, and hopefully you noticed we already did number 4. Okay, so now that we kind of know how to do the numbers, now we're going to do the variables as well. And if you want to take a second and write these note down, you can. But your even exponents are your perfect squares. So when taking the square root of a variable, you break it into the largest even exponent and its other factor, and then take the square root. So this is what I mean by that. So if this is even, which it is, when I take the square root of it and pull it outside the radical sign, I just divide it by 2. So the square root of a to the 4th is a to the 2nd. Because it's even, there's nothing left under the radical sign. Okay, again, this 10 is even. So to take the square root of it, I just divide it by 2. So c to the 5th is the answer. Now this one's a little different because it's odd. So what I do here is I break it into the highest amount of even f's that I can, which would be f to the 8 times f. This one is my perfect one. So the square root of f to the 8 is f to the 4th, because I take half of it, and then I leave the f, that's got the 1 exponent, underneath the radical sign. So that's my answer there. Same thing here for the p's. The highest amount of even I can do is p to the 24th times p to the 1st. That's still under the radical sign. I'm going to take the square root of the highest even, which is p to the 12 on the outside, and that p is still on the inside. So hopefully you understand how the letters or the variables work. Remember, we're going to go with evens being perfects. Okay, so now we're going to put it all together and see what we can do. The first thing I'm going to do is write it all out. So I'm going to start with the number. So I'm thinking 9 times 5 for 45. Okay, 9 is my perfect. 5 is not. A to the 4th is perfect because it's even. B to the 5th is not. So I'm going to change B to the 5th to B to the 4th times B. I'm going to circle the B to the 4th because that's perfect. And then C to the 6th is also perfect. So I'm going to take the square root of all the ones that are circled. So on the outside, the square root of 9 is 3. The square root of a to the 4th is a to the 2nd. The square root of b to the fourth is b to the second. The square root of c to the sixth is c to the third. And then what's left underneath are the ones I didn't take the square root of, 5b. This is my answer. Okay, so I'm just putting it all together here. All right, you try number 7. Push pause and give it a try. All right, I'm thinking 25 times 6. Let me make sure that's 50. It is. Okay, 25 is my perfect. X squared is perfect. Y to the 5th is not, so I'm going to change it to y to the 4th, y. Y to the 4th being perfect. And z to the 6th is perfect. So I'm taking the square root of 25, which is 5. The square root of z squared, or x squared, is x. The square root of y to the 4th is y to the 2nd. And the square root of z to the 6th is z to the 3rd. And what's left underneath are the items I did not circle. So 6y stays underneath. How'd you do? If you got it, give yourself a pat on the back. If you missed it, I hope you figured out where you went wrong. Okay, and then we'll try not to make that mistake again. That's kind of how we learn. All right, try number 8 and 9. See if you come up with those. I'll give you a second. All right, so 98. If I divide that by 49, yep, 49 times 2. That's what I want to use. B to the 4th, D. E to the 2nd, E. And F to the 6th, F. 49 is perfect. D to the 4, E to the 2nd, F to the 6th. Everything else stays underneath. So square root of 49 is 7. Square root of D to the 4th is D to the 2nd. E to the 2nd is E. And F to the 6th, if I take the square root, is F to the 3rd. Left underneath is 2, D, E, and F. This is the answer. If you got it, big pat on the back. Nice job. If you didn't, I hope you found your mistake. Let's see, 108. That one doesn't come as easy. Let me use my calculator. 108 divided by, let's try 36. Ooh, I got it on the first try. And I was totally guessing. I knew it couldn't be 49, or at least I didn't think it could be. And everything else seemed too high, so I tried 36 and it worked. But you would just use your calculator. 36 divide 4. 36 divide 9, 36 divide 16, 36 divide 25, 36 divide 36 until you found it. And I just happened to pick 36 off the bat. So 36 times 3, 36 is my perfect. M to the 8 is perfect. And n squared being perfect. So square root of 36 is 6. M to the 8th is m to the 4th when I take the square root. And n to the 2nd is just n. Underneath is 3n. This is the answer. Good job if you got it. All right, so we got some fraction stuff going on here. Just like on that connection to prior learning page, we can separate them. So this is the square root of 128 over the square root of 225. I hope you're realizing that the square root of 225 is a perfect. That's just 15. And then the square root of 128, we're going to figure out what the perfect is. 128's not. Let's see, 128 divided by 64 maybe? No, that's way too big. How about 36? Oh, I'm multiplying. That's why it's not working. 36 doesn't work. Let's try 64 again. I'm thinking 64 works. 64 clear. That works. So we're going to do 64 times 2. And then my 64 is my perfect. So square root of 64 is 8. So 8 radical 2 over 15. Okay, the 15 came from the square root down here. And the top, I'm doing exactly like I was doing before. And then I just have to check these two to see if they have a common factor, and they don't. This is the answer. Okay, let's try this one. Okay, so square root of 81, I could definitely do that on the bottom. That's 9. Okay, and then on the top I have negative the square root of 243. So there's like a 1 right here. It's implied. It's like negative 1 times the square root of 243. So let's break that up. 243, let's see. 243 divided by 9 maybe? 27. 9 times 27. Well, if I break that up, that gives me 9 times 3. Let's try 81. You see the two 9s? 243 divided by 81 is 3. So 81 times 3. 81 being the perfect. Does everyone see that? Okay, so if I take the square root of 81, that gives me negative 9. The negative was already there. Took the square root, got 9, radical 3 over 9. And I look at these two. Can you cancel a 9 over a 9? You totally can. That becomes a 1, and so does that. So my answer is just negative 1 radical 3 over 1, or you could write that as negative radical 3. That's the answer. All right, you push pause and try 13 and 14. See if you can come up with it. All right, so we're going to factor or separate the radical sign like this. Both of these are perfect. So on the bottom we get 4a. On the top, I'm thinking 4 and 10. Yeah. So if I take the square root of 4, that gives me 2. 2 radical 10. And on the bottom, that's 4a. These two cancel. 2 will go into both. So 2 divided by 2 is 1. 4 divided by 2 is 2. So my answer is radical 10 over 2a. Good job if you got that one right. That one was tough. All right, and if we separate here, that one's perfect. And square root of 36. So the bottom number is 6. And the top number, let's see, 180. 36 maybe? 180 divide 36. Yep, 36 and 5. 36 times 5 is x to the 4th. That one's perfect, and so is the 36. So this is 6 x to the 2nd, radical 5 over 6. The 6's canceled, don't they? So my final answer is x squared radical 5. 6 divided by 6 is just 1, so they go away. And you could write it as 1x squared radical 5 over 1, but it's not necessary. All right. And I'm all done. So your assignment is on big ideas, just like it always is. Give them a try. See how you do. I'm on Canvas if you need me from 12 to 1 every single day. None of you ever come on there. It makes me kind of sad, but I would very much like you to. I'm sitting there waiting. So if you have any questions about radicals, this would be the first time we're doing something like this. So feel free to tune in. Thanks. Bye.